All right, so we're moving on to session 2 for our lesson 12. We're still adding fractions, but we're going to focus on having two denominators, or those bottom numbers that are not the same. So let's get into it. The warm-up I'm not going to do for this one. I feel it introduces a technique that we won't really use all that much. So we'll skip right to page 231. And you should see a kayak right at the top of the page. All right, so Maggie paddles her kayak half a mile to an island. Then she paddles 4/5 mile to a beach. How far does Maggie paddle her kayak in all? So classic example of if you see that phrase in all, that that does always mean to add. So again, sometimes with these word problems, there's not much creativity in it. You just kind of look out for similar phrases. For this one, I'm going to look at our denominators, the 2 and the 5, and I want to go over the multiples of both of those. So multiples of 2. These we're going to have 2, 4, 6, 8, and let's stop at 10. And then multiples of 5. You've got 5 and 10, and I can stop right there because, again, you want to find, using your multiples of the denominators, you want to find the number that is the same for both. And we usually go for the smallest one. That means our math will be fairly easy. So we're going to decide on 10. So we're going to have 1/2 plus 4/5. And if we want our denominator to be 10, we have to create an equivalent fraction. Again, your IXL today will be involved with that. So let me show you what's working for this. So we have 2 down here for this denominator. To get it to be a 10, we need to multiply by 5. We do that for top and bottom. So that gives us 5/10. For this 5, we got to multiply by 2 to get to 10, which means we do the same at the top. And it means we get 8/10. And that gives us 5/10 plus 8/10. And with adding fractions, we only add up those top digits and leave the bottom alone, because we already know how many parts to a whole there are. So we have 13 parts of 10, or 13/10 of a mile. And we can change that to a mixed number, but we'll get into that later on. Okay, go ahead and turn the page. This is a technique I really don't want to get into, but I'll go over it quickly because it does relate to some of the questions on page 233. But the theory with this is you create these things called fraction bars. This fraction is 1/2, so that means we're going to show 1 part shaded in of a 2-part bar. For this one, it's 4/5, so 4 of those are shaded in. And the theory is to take your 2 fraction bars and split them up into equal parts. So for example, if we do this, and it does the same thing down here at the bottom, then it makes sense like that. So this basically, I'll just extend these lines, make it look a little neater. Okay, so that breaks up these bars in the part where it has 10 equal parts for each one. And then you just count them up. So we have 1, 2, 3, 4, 5. So that would be 5/10. It says 1, 2, 3, 4, 5, 6, 7, 8. And that is 8/10. And as you can see, 1/2 and 5/10 are equivalent fractions. 4/5 and 8/10 are equivalent fractions. And we add those up, and it will give us our 13/10 that we got for the first one. Next is the classic technique. Well, actually, we did this before once we found our common denominator. this is where we did that situation with multiplying both sides here, and to create that common denominator of the 10. And that gave us our 13 tenths. So two different techniques for this point. You can use fraction bar, but I would probably go with our classic example here. All right, number 1, explain why both fraction bars in picture are divided into 10 equal pieces. Because 10 is a multiple of 2 and 5. And like I said yesterday, you can just multiply the denominators together to get your guaranteed common denominator. We'll focus more on finding the smallest available one, so we don't have to reduce as much. Right, the total distance Maggie paddles is a fraction, 13 over 10. Right, the total distance Maggie paddles is a mixed number. So got a little space here. How mixed numbers work is you see how many 10s you can pull out of your top number. I know I can get at least one group of 10. So there's my whole number. And if I do 13 minus 10, it gives me 3. And that will give me 1 and 3/10. I would accept either answer because they're both the same. Look at the denominators and model it. What do you notice about the relationship between the original denominators, 2 and 5, and the common denominator, 10? Well, we kind of already noticed that. But let's put it in more mathematical terms. It's the product, again, the answer of two multiplication, of a multiplication problem. It's the product of the original denominators. Okay, number 4. Is 10 the only common denominator for 2 and 5? No, you could use any multiple of 10. You're just going to get a much bigger number that can reduce to your final answer. So you can use 10, 20, 30, 40, etc. It just means any multiple of 10. Explain how to add two fractions with unlike denominators. Well, you find the common denominator. And use that to make, see if I can fit all this here, equivalent fractions. You should have enough space on yours. Equivalent fractions. There you go. All right. Go ahead and skip 6. And let's look at 7. All right, Hank practices 5/8 of the words of his spelling list on Monday. He practices another 1/4 of his list on Tuesday. What fraction of his spelling list has Hank practiced so far? Show your work. So let's take a look at this. So put 5/8 down here. And we're going to add 1/4. So this is a problem where we don't have to list multiples and do much multiplication here, because if you look at your original denominators, we already know, you would know that 4 times 2 would give us an 8. And we could just leave this 5/8 over here just how it is. We can leave that alone. So let's do times 2, and that would give us 2 8s. So we've got 5 8s plus 2 8s. Maybe write that down here. And that will give us 7 8s. So he did 7 8s of his list for that. So again, sometimes it's just easy to keep one of the fractions if you can easily turn the other one to an equivalent fraction with the same denominator. Yeah, sometimes it's right there in plain sight. Number 8. What is the sum of 7, 6, and 5/8? Okay, so this one is not as convenient as the last one, but 7, 6 plus 5/8. All right, so here are our original denominators. Up here, let's show the multiples of these two numbers. So for 6, I've got 6, 12, 18, 24, 30. For 8, I've got 8, 16, 24. And I can stop right there because that 24 is our common denominator. We could have done 8 times 6 and got a common denominator of 48. That's totally possible, but let's go with the smaller, more reduced one to give us easier numbers to work with. All right, so here is equivalent fraction. I know 6 times 4 gives me 24. For 7 times 4 is 28. And there's that one. I know 8 times 3 is 24. And so 5 times 3 is 15. Which gives us 28 24ths plus 15 24ths. I'm not expecting you to know how to do that one in your head. So over here, let's put 28 plus 15, although some of you probably could. That'll give us 43 24ths. Or if we want to change that to a mixed number, how many groups of 24 can I take out of this? I can get one group out, and then I'll have 19 24ths left for that one. And one last problem. All right, so this one's good. So let's put down 2/3 plus 5/12. Okay. You're looking at your original denominators of 3 and 12. And you probably already see that 12 is a multiple of 3. So we can create an equivalent fraction with this one on the left and keep this guy right here. All right, so let's put our equal sign. We need to multiply by 4 to get 12. That means you got to do by 4 by the 8. So we have 8/12 plus 5/12, and 8 plus 5 is 13. And look at that. Answer C matches up with that. All right. Let's look at, all right, so our, you guessed it, our IXL today will be equivalent fractions. That'll be K4, so we'll skip K2 and K3. You can go to IXL activity to 70%, which is your bronze medal, and then you should be done. I'll be sticking around to help you on that if you need any help after you get started.